7.13. We're going to analyze circuits in parallel. So we'll build and analyze circuits in parallel. We'll figure out the current and voltage used by each component, and we will explain what happens in a circuit with a light bulb and a resistor in parallel. So here we have a circuit with two light bulbs in parallel. The battery provides 9 volts. How much voltage does each light bulb use? Let's grab our voltmeter. And we see that the first light bulb uses all 9 volts, and the second light bulb uses all 9 volts. So both light bulbs use 9 volts. That's why light bulbs are brighter in parallel. Okay. What about this one? The resistance of a circuit in parallel. The resistance of the entire circuit, the equivalent resistance, we can add this time. We're going to have to figure out what it is. So what is the current at A? Well, V equals IR. So that means 9 equals the current times 10. Divide both sides by 10. And we get 0.9 equals I. So the current is 0.9. And that makes sense. If we take an ammeter here, we see that the current is 0.9. Numbers are the same for circuit at B, so the current must also be 0.9. Sure enough, right here, 0.9. So the total current is going to be 0.9 plus 0.9 equals 1.8. In a parallel circuit, the currents can add. In a series circuit, the resistances add. So parallel, currents add. When things are wired in series, we add the resistances. And sure enough, if we look at our circuit, we see that here is 1.8. We got 0.9 here, 0.9 here. And we see that the electrons go faster in this part. Okay. So what is the resistance of the circuit? V equals IR. The voltage is 9. The current is 1.8. Divide both sides by 1.8. And we get 5 equals R. Let's see. 9 divided by 1.8, which is 5. So the resistance is 5 ohms. As it turns out, the resistance is actually half of the tens. One more example. This time, this is 12. And this one is 6. Okay. Let's see. So V equals IR. Voltage is 9. Current we don't know. Resistance is 12. Divide both sides by 12. And we get 0.75 is the current for the at A. Let's check to see if that's right. Yep, that's 0.75. For B, 6. Divide both sides by 12. And we see that 0.5 is the current, as we can see right here. Whoops. The resistance is 6. Divide both sides by... okay. So V is actually 9. I made a mistake here. The voltage is 9 and the resistance is 6. So that means we divide by 6. 9 divided by 6 is 1.5. So that's why it's always worth checking. And we can see that there's more current here. The electrons are moving faster than here. Okay. So the total current is going to be 0.75 plus 1.5, which is 2.25. So the resistance, let's check the total current. And of course, it is 2.25. So to find the resistance is 9 equals I times 2.25. Divide both sides by 2.25. And I get 4 equals I. R. So the resistance is 4 ohms this time. Okay. So what happens if we have a circuit with a light bulb with a 12 ohm light bulb and a 120 ohm resistor? So remove this light bulb. Of course, this light bulb stays on because it's a circuit in parallel. But what happens when we add this resistor in here? What's going to happen to the current here and the voltage used? Let's see. So this is going to be 120 ohms light bulb. Much more resistant than our light bulb. Let's see. Whoops, not yet. Nothing changes. As you see, the current and the voltage for this light bulb stays the same. Why? Because each component uses voltage from the battery independently. So putting a resistor here will not affect this part of the circuit. And that's it.